What if the safest moments of your life are the ones you never noticed? Not the dramatic rescues you retell as stories, but the quiet seconds where everything could have tipped the other way and didn't. The coffee you almost skipped, the bus you almost caught, the message you almost sent. A tiny delay at a traffic light, a sudden change of mind. Ordinary life is stitched together from microscopic pivots, and most of the time, we call them nothing at all. But there is a strange possibility, one that makes those pivots feel less like random noise and more like a hidden structure underneath reality itself. Sometimes you call it luck, sometimes you call it intuition, sometimes you just shrug and move on. But physics has a habit of turning shrugs into questions, because a shrug is usually a place where your mind has quietly accepted something it cannot actually explain. That possibility is often discussed under a loaded phrase, quantum immortality. The phrase is provocative, and it can mislead people into thinking it's about invincibility or cheating death. It isn't. It does not promise eternal youth, and it does not protect you from pain or danger. It is not an excuse to take risks or to treat reality like a game. It is a thought that falls out of a particular way of reading quantum mechanics, and it is unsettling for a different reason. It suggests your experience may only ever continue along the outcomes where experience remains possible, while other outcomes unfold elsewhere, unseen. If that sounds like science fiction, keep your skepticism close. Tonight isn't about believing. It's about understanding what the logic actually says, where it comes from, and where it breaks. Before we go further, here are the ground rules for tonight. We are not turning your life into an experiment. We are not turning fear into entertainment. We are going to do the opposite. Slow down, breathe, and follow the logic with care. If you enjoy calm, long-form space and physics documentaries that take big questions seriously without screaming at you, consider subscribing and leaving a like. It helps this channel keep making slow investigations. Now, lower the lights a little, let the day loosen its grip, and step with me into the quiet corner of physics where reality stops behaving like a single story. Quantum mechanics is the most successful description of the microscopic world humans have ever built. It predicts the behavior of electrons and atoms with precision so extreme that engineers use it to design the chips inside your phone. It tells us why matter is stable, why stars shine, why chemistry works at all. And yet, the theory carries a paradox at its core. At the smallest scales, nature does not behave like solid objects with definite properties waiting to be discovered. Instead, it behaves like a cloud of possibilities, described by something called a wave function. The wave function is not a poem. It is a mathematical object that lets you calculate the probability of different outcomes when you interact with a system. If that sounds abstract, the experiments are not. Consider the most famous demonstration in all of physics, the double-slit experiment. When you let a stream of particles pass through two narrow openings, you get an interference pattern, the kind of pattern waves produce. It is as if each particle behaves like a wave of possibility, exploring multiple paths at once. But when you try to learn which opening the particle used, the interference vanishes. The result becomes clean and definite, like ordinary billiard balls. The very act of extracting which path information changes what you see. Then you measure something more directly. You ask a question of reality. Where is the electron? What is the photon's polarization? What energy level is the atom in? And suddenly, you do not get a spread. You get a single, definite result. One location, one reading, one number on a screen. If you repeat the measurement many times, you build up a distribution that matches the wave function's predictions with eerie accuracy. The theory works. The statistics work. And still, each individual run gives you only one outcome, as if the universe tosses a coin and commits. This is the measurement problem, and it sounds almost innocent until you stare at it long enough. The equations that govern the wave function, how it changes over time, never include a moment where possibilities suddenly turn into one reality. The evolution is smooth, continuous, and perfectly well defined. Then, in every lab, every time, we see something else, a sharp result. So physicists traditionally add a second rule. When a measurement happens, the wave function collapses into a single outcome. But the word measurement hides a trap. What counts as a measurement? A detector? A camera? A human eye? A molecule in the air? Where is the boundary between a quantum system and an observer? If everything is made of atoms, and atoms obey quantum rules, why would there be a special moment where the rules suddenly change? For decades, the most common response has been practical, almost impatient. Use the math, get the right predictions, build the technology. Don't ask too loudly what it means. That attitude gave us lasers, transistors, MRI machines, and the modern world. But it did not make the crack go away. The question stayed, quietly waiting in the foundations of the theory, like a fault line you can pave over but never truly erase. In the 1950s, a young physicist looked at that fault line and refused to look away. His name was Hugh Everett III. He was brilliant, ambitious, and deeply dissatisfied with what he saw as a philosophical patch holding quantum mechanics together. The standard story said that measurement causes collapse. The wave function stops being a spread of possibilities and becomes one outcome. But collapse was not part of the main equation. It was an extra rule, bolted on to match our experience. Everett asked a dangerous question. What if the bolt is the problem? What if collapse is not real? Everett proposed a radical alternative. What if collapse never happens? What if the wave function always evolves smoothly, and the appearance of collapse is simply what it feels like to be an observer inside one branch of a larger reality? In Everett's view, the universe does not choose one outcome and erase the others. All outcomes occur, not as fantasies, not as metaphors, but as real branches of a single underlying physical description. When a quantum event has multiple possible results, reality contains each result, and the observer becomes entangled with them. From the inside, each version of the observer experiences one definite outcome and calls it what happened. This idea later became known as the many worlds interpretation. The name itself is a trap because it makes people picture separate universes floating far away like soap bubbles in space. The worlds are not distant places. They are overlapping descriptions of one larger quantum state, separated by a process called decoherence. Decoherence is what happens when a quantum system becomes entangled with its environment, air molecules, radiation, thermal noise, until different outcomes can no longer interfere with each other. The branches become effectively isolated, not by a wall you can see, but by a loss of the delicate phase relationships that make interference possible. Decoherence matters because it answers the first practical question people always ask. If other outcomes exist, why don't we see them? In the branching picture, you don't see them for the same reason you don't hear a whisper happening inside a perfectly sealed room. The information cannot leak back into your branch in a way your senses can access. The branches don't line up again. They don't merge like rivers. They simply diverge, and from the inside, each branch feels like the only one that ever existed. Now the story becomes personal. If reality branches, the observer branches too. There is a version of you in each branch, each one experiencing a single, definite outcome, each one believing it is the only you. From the inside, you do not feel like a swarm. You feel like one person moving through one life. Many worlds suggests your one life may be your local perspective inside a much larger structure. Like a traveler who can only remember the road they stayed on, even if the map contains countless roads leaving the same intersection. And this is where the unsettling phrase returns. If there are branches where experience continues and branches where it does not, then experience can only ever be found along the continuing branches. Not because you are protected, not because the universe cares, not because anything is meant to happen, simply because non-experience cannot be experienced. You can't look out from an absence. You can't report from a place where reporting is impossible. It is a statement about perspective, the same way you can never witness your own sleep. You only ever witness waking. So tonight, we are not going to pretend this is settled. We are going to treat it as a working theory, a proposal that makes quantum mechanics internally consistent by removing the mysterious collapse and accepting the consequences. Some physicists love many worlds for its simplicity. Others reject it because simplicity is not evidence. And even if many worlds is true, quantum immortality might still fail if consciousness and identity do not track branches in the way the argument assumes. The word "you" is doing a lot of work here, and we are going to inspect that work carefully instead of assuming it. But here is what we can do, safely and honestly. We can follow the story to its roots. We can watch how a single stubborn question, "Where did the other possibilities go?" turns into a worldview where the possibilities never go anywhere at all. In the next part, we step into Princeton in the 1950s, into a small room with a young graduate student and an equation that refuses to explain what we see. We'll trace the moment the universe stopped collapsing and started multiplying, and we'll ask the first question that makes everything else inevitable. If the wave function never collapses, what exactly are we? The night the universe refused to collapse. It's easy to picture quantum mechanics as a set of equations sitting safely inside textbooks, far from real life. But in 1954, in Princeton, it didn't feel safe at all. It felt like a question that would not stop breathing. A graduate student named Hugh Everett III sat with pages of math that behaved perfectly on paper and behaved strangely in the world. The Schrödinger equation was clean. It was deterministic. It described a wave function evolving smoothly, like a river flowing downhill. And yet, every time a physicist measured something, the river seemed to shatter into a single droplet, one outcome, one result, one reality. The textbooks called it collapse. The labs treated it as normal. Everett treated it as the one thing no one had actually explained. He wasn't the first to notice the crack. The founders of quantum mechanics had been wrestling with it since the 1920s. Niels Bohr and Werner Heisenberg built what became the dominant story, the Copenhagen interpretation. In that story, the wave function is not a literal description of reality. It is a tool for predicting what you will observe. Ask nature a question, and nature answers with a definite result. The wave function collapses into that result, and the other possibilities are no longer physically relevant. This approach worked. It let physicists calculate atomic spectra, chemical bonds, the behavior of semiconductors. It was a practical peace treaty. Stop asking what the wave function is and focus on what it predicts. But a peace treaty is not the same thing as a solution. Everett stared at the same problem every curious student eventually stares at. If collapse is real, what causes it? If it only happens during measurement, what is measurement made of? Detectors are made of atoms. Scientists are made of atoms. Air molecules are made of atoms. If the quantum rules apply to atoms, why would a pile of atoms arranged into a measuring device suddenly force the rules to change? Where is the boundary line between the quantum world and the classical world? And why does that line exist at all? The Copenhagen answer was often poetic and evasive. You must describe results in classical language. You cannot speak meaningfully about the system between measurements. The question is not what is real, but what can we say about what we observe? Everett heard that and felt the same irritation you might feel when someone responds to a simple question with a beautiful speech that never actually answers it. So he did something dangerous in physics. He took the equation seriously everywhere. The Schrödinger equation does not contain a collapse mechanism. It does not say, and then measurement happens and everything snaps into one outcome. It just evolves the wave function forward in time. Everett asked, what if we stop adding collapse as a second rule? What if the wave function never collapses at all? Not for electrons, not for detectors, not for brains, not for entire laboratories. What if the entire universe is one quantum system, evolving smoothly under one set of laws, with no special exceptions? The immediate reaction most people have is, but then why do we see definite outcomes? Because we do. You look at a screen and you see one dot, not a fog. You read a detector and you get one number, not a superposition of numbers. You live one day, not 1,000 days at once. Everett's answer was not that definite outcomes are illusions. His answer was that definiteness is local. When a measurement happens, the system doesn't collapse. The system becomes correlated. The measuring device becomes entangled with the measured object, and you, the observer, become entangled with the device. The wave function branches into components that no longer interfere with each other. Each component contains a consistent story, a detector showing this result, an observer remembering this result, a world where that result happened. The other components contain other consistent stories. All of them exist in the full wave function. But from inside any one branch, you only ever experience the story in front of you. You call it reality because it is the only reality you can access. This is the seed of many worlds, even if Everett did not advertise it with that name. He described it as a relative state formulation because the outcome you see is relative to the state you are in. There is no single global outcome. There are multiple outcomes, each paired with a corresponding observer state. From the outside, the universe is still one object, one wave function. From the inside, it feels like a single world because you are embedded in one branch of the larger structure. There is a technical piece here that matters, and it's the reason this isn't just philosophy dressed up in math. It's decoherence. Decoherence is what happens when a quantum system becomes entangled with its environment so thoroughly that different outcomes lose the ability to interfere. In the double-slit experiment, interference exists only when the paths remain coherent, meaning the wave-like phases remain aligned. The moment information about which path leaks into the environment, even in tiny ways, coherence is effectively destroyed. The system behaves as if it has chosen a definite outcome, not because it truly chose, but because the branches are no longer able to recombine in any practical sense. The world becomes a set of non-communicating histories. They are still present in the full mathematical description, but they are sealed off from each other by the irreversible spread of information into countless degrees of freedom. Decoherence is not a magic wand. It doesn't prove many worlds, but it explains why branching would feel like collapse. The classical world is not non-quantum. It's quantum systems that have decohered so hard that interference is essentially gone. You don't see superpositions in everyday life for the same reason you don't see a drop of ink spontaneously reassemble itself in water. The information has dispersed too widely. The correlations have spread too far. The reversals are possible in principle, but hopeless in practice. That is why the world looks definite, not because the wave function truly collapses, but because the branches have become dynamically isolated. If you accept this picture, even provisionally, it changes the meaning of a simple sentence like, "Only one thing happened." In Everett's universe, "one thing happened" is something you say from inside a branch. It's a statement about your point of view, not a statement about the global structure of reality. There is your outcome, and there are other outcomes, equally consistent, equally real within the total state, but unreachable to you. Each branch contains an observer who believes, with complete sincerity, that theirs is the only timeline. And none of those observers can directly prove the others exist, because the proof would require reversing decoherence, gathering lost correlations from the environment, and forcing branches to interfere again. In ordinary conditions, nature does not give you that ability. So we arrive at a strange kind of honesty. The Copenhagen interpretation says collapse happens and refuses to explain how. Everett says collapse does not happen and accepts the consequence that reality contains more than one outcome. Copenhagen keeps one world and introduces a special rule. Everett keeps one rule and pays for it with many worlds. And in physics, when two stories predict the same experiments, the fight often moves into the foundations. Which story is cleaner? Which one demands fewer unexplained exceptions? Which one we can extend without breaking? But the moment you allow the wave function to keep everything, one uncomfortable question follows you out of the classroom and into your own life. Not about gadgets or labs, about you. If the observer is part of the quantum system and the system branches, then in what sense are you a single continuous self? What exactly is you inside a branching reality? Is identity a thread, a process, a pattern, a perspective? And if the world contains branches where your experience continues and branches where it doesn't, what does that imply about the only experiences you can ever have? That is the pivot we're heading toward. Not as a dare, not as a thrill, as a careful, slow inspection of what the logic actually implies when you take the equation seriously. In Part 3, we go deeper into the mechanism, what branching really means, what probability means when every outcome occurs, and why the most unsettling consequences are not about the universe being big, but about the universe being generous with possibilities, while your awareness can only ever ride along a narrow path through them. Here is the trap your mind falls into the moment you hear many worlds. You picture a clean fork in the road. One branch goes left, one branch goes right, and both feel equally likely. It's a simple image, and it's almost never how the mathematics behaves. In the real structure of quantum theory, branching is not a neat split into two identical copies. It is a spread of possibilities where some outcomes carry most of the weight and others survive as faint, razor-thin threads. And what you call chance stops being a question of whether an outcome exists. In this framework, outcomes do not beg for permission to exist, they exist. The real question is, how much of reality flows into each one? Quantum mechanics assigns an amplitude to every possible result. The amplitude is not a probability yet, it is a complex number, a strange kind of quantity with magnitude and phase. But when you take its magnitude and square it, you get the Born rule, the probability of observing that result. In the ordinary single-world story, that probability has a comfortable meaning. A measurement happens, one outcome becomes the world you live in. The probability tells you which outcome you should expect to see. In a branching universe, that meaning breaks, because which outcome becomes real is no longer the right question. They all become real. So the Born rule has to be reinterpreted as something colder and more abstract, a measure of branch weight, the distribution of reality across outcomes, the thickness of the different futures. Think of it like a spill instead of a dart. In the classical picture, the universe throws a dart and lands on one point. In the branching picture, the wave function spills paint across the board. It spreads into many regions at once. Some regions get drenched, some get barely dusted. Every region with any paint exists. But if you were embedded inside the paint, your typical experience would come from the drenched regions, not the wispy edge. That is what branch weight is trying to capture. It isn't a moral judgment. It isn't a declaration that thin branches are fake. It is a claim about what most of the measure contains and what most observers should expect to find themselves seeing. This is where the argument turns sharp, because a simple question exposes the pressure point of the entire interpretation. If every branch exists, why should thickness matter at all? Why should more weight translate into more likely when everything is equally real? This is the probability problem, and it is not a footnote. It is the philosophical nerve that runs straight through the heart of many worlds. People have tried to solve it in different ways. Some argue that rational decision-making forces you to treat branch weights like probabilities, because any other betting strategy collapses into incoherence once you account for branching futures. Some try to derive the Born rule from the structure of quantum states themselves, as if the mathematics leaves you no choice. Others describe probability here as a special kind of self-locating uncertainty. Before a measurement, you don't know which future version of you will become, even though all future versions will exist. You don't need the full technical machinery to feel the consequence.
Many worlds is not anything can happen. It is everything that can happen does happen, but not in equal proportion. Rare events do not require a magical exception. They simply live in thinner parts of the wave function. And that is the moment the universe becomes more unsettling than it first sounded, because it means your intuition about likelihood can be simultaneously correct and incomplete. Correct from the outside, incomplete from the inside. Here is the second mistake people make. They hear thin branch and they translate it into not really real. But thin does not mean unreal. It means rare. A rare outcome is still a fully lived outcome. From the inside, existence does not come with a label that says 0.0001%. You do not wake up and feel yourself made of less reality. You just wake up. That's the cruel elegance of it. A thin branch can contain a life as vivid, as emotional, as convincing as any thick one. The branch does not announce its own improbability to the people living in it. Now bring this into the texture of your daily life. In ordinary thinking, probability describes the world. In a branching world, probability describes your position inside the world. That sounds like wordplay until you test it against something concrete. Suppose two outcomes exist after an event. Outcome A has almost all the weight. Outcome B has a sliver. Most of the measure is in A-type branches. There will still be a version of you in B. That version will remember the past and insist, sincerely, that B happened, and it will be right, locally. But B is still a thin thread in a much thicker fabric. This creates an eerie split between two perspectives that usually agree. From the outside, you can talk about what is typical, what occupies most of the weight, what most observers will report, what you should expect if you're thinking statistically. From the inside, you can only talk about what is experienced. And experience has a brutal filter baked into it. You cannot experience branches in which you do not exist to experience them. That fact is obvious, and yet it becomes explosive once you realize it can bias the only story you ever personally have access to. It is the same logic behind the anthropic principle in cosmology. We find ourselves in a universe compatible with our existence because a universe incompatible with observers contains no observers to notice it. In a branching framework, the same selection effect can apply to branches. Your awareness, by its very nature, is confined to the subset of reality in which awareness continues. Not because you are favored, not because you are protected, because not being there is not a viewpoint. That is the core mechanism, stated carefully, without drama. If an event has outcomes where you continue and outcomes where you do not, then there will be branches where you continue as long as continuation has any non-zero weight. And because branches where you do not continue contain no future experiences for you, your first-person narrative is automatically restricted to the continuing ones. That restriction is not a miracle. It is a consequence of what it means to have a point of view at all. But this is exactly where sloppy thinking tries to sprint ahead. People turn this into a guarantee. I will always survive. The honest version is narrower and stranger. Many worlds does not say you are safe. It does not cancel consequences. It does not rewrite the brutality of statistics in the branches that carry most of the weight. In most of the measure, dangerous situations end the way dangerous situations usually end. If you watch outcomes from the third-person perspective, if you are simply counting what happens in the thick parts of the wave function, there is no magical immunity. Reality remains reality. What survives careful scrutiny is not a promise of a good outcome, but a claim about experience. You cannot have experiences in branches where you are not there to have them. That sounds harmless until you realize how it presses against your idea of identity. What are you, exactly, in a world that branches? Are you a specific arrangement of atoms that persists through time? Then branching looks like copying. Multiple later versions share a past, then diverge. Are you a stream of consciousness, memory, personality, the felt sense of I that carries forward? Then branching becomes much darker, because there isn't one future stream, there are many. Each future stream will claim to be you, and in the only way that matters from the inside, each will be correct. It will remember being you. If identity is continuity of experience, identity can continue along multiple branches at once. If identity requires uniqueness, branching breaks uniqueness. The idea of a single self starts to look like a classical approximation, a useful simplification, the way solid objects are useful simplifications in a universe that is mostly empty space.
You feel like one person because you only ever occupy one path. But the mathematics does not care about that feeling. It describes the tree, not your comfort. And the tree is real in the sense that matters. Every day, your body is a storm of microscopic events, molecular interactions, ion channels, thermal jitter, tiny mutations, tiny repairs, tiny failures. Most of those microscopic differences wash out, some amplify. Over time, small differences become different lives, different jobs, different cities, different relationships, different recoveries, different endings. In a branching picture, your story is not a single line. It is a tree, and you are one path through it, unaware of the others because awareness is local. So, now, the unsettling possibility takes shape without needing any theatrics. First-person experience may be biased toward continuation in a way your instincts cannot model cleanly. From the outside, you can assign weights and talk about what is typical. From the inside, you only ever find yourself where experience continues, because those are the only places an inside exists. If continuation remains possible at all, there is a branch in which it does. And if there is a branch in which it does, there is a story being told there. A narrative that never contains its own end, because an end contains no narrator. The moment you hold that idea steady, you can feel the real question forming underneath it. Continuation is not the same thing as well-being. Continuation is not a promise of health or peace or a life you would choose. In a branching universe, continue can be brutally minimal. The dynamics do not negotiate with your preferences, they simply evolve. And if your awareness is chained to where awareness still exists, then the future you experience could, in principle, drift toward thinner and thinner branches. Not because you are special, but because the alternative is silence, and silence never reports back. Picture what your life feels like right now. One room, one screen, one body, one uninterrupted stream of moments. It feels like a single track running forward, and that feeling is the main reason the many worlds idea sounds like a prank the universe is playing on us. Because if reality is branching constantly, why don't we ever see the seams? Why don't we catch a glimpse of the other outcomes flickering beside our own, like reflections in a dark window? The answer is not mystical. It is mechanical. It is quiet, and it is brutal in its simplicity. The universe does not hide its branches behind a curtain. It hides them inside the ordinary act of touching. Every interaction is a kind of information leak. Every photon that bounces off your skin and flies away is a tiny receipt that says, "This happened here, like this." Every molecule of air that taps a table and ricochets is a microscopic witness. And witnesses ruin superpositions. In the early days of quantum theory, people spoke about measurement like it was a special ritual. You look, and the wave function collapses. But what we learned later is that the environment is always looking. Not with eyes, with collisions, with heat, with vibration, with the constant chatter of particles exchanging energy and momentum. This is decoherence, and it is the closest thing physics has to a visible hinge between the quantum world and the world you and I wake up inside. Decoherence does not pick a single outcome. It does something almost colder. It makes the different outcomes stop talking to each other. It takes one blurry cloud of possibilities and splits it into branches that can no longer interfere, no longer combine, no longer
cancel each other in the way waves do. The mathematics stays smooth, no magical snap, no divine choice. Just a relentless spreading of information into the surroundings until the branches become effectively separate histories. Think about the double-slit experiment again, but this time imagine something even simpler. A single grain of dust floating in sunlight. In principle, that dust could be in a superposition of positions, here and there at the same time. But in practice, it isn't. Why? Because light is constantly striking it, air is constantly bumping it, the dust is constantly radiating heat. The environment is continuously extracting which path information, tiny bits of where it was and what it did, and scattering that information outward into the universe. And once that information is out there, the superposition is not destroyed, but it is shredded into branches that cannot recombine. This is why the many-world story is not a flashy science fiction split where you can step sideways and meet an alternate you. The branches are not separated by distance. They are separated by lost coherence, by a kind of irreversible bookkeeping the universe performs every time an interaction spreads information beyond your ability to collect it back. In a clean lab with carefully isolated particles, you can preserve coherence long enough to see interference. You can make quantum weirdness stay weird. But the everyday world is a roaring storm of interactions, and that storm is a decoherence machine. It is constantly forcing reality into stable, classical-looking patterns. If many worlds is right, the worlds are not created by dramatic choices. They are created by microscopic, mundane events that happen trillions of times a second. The branching is not rare. It is the default. The only rare thing is keeping branches connected long enough to notice their wave-like nature. That is what quantum engineers fight for when they build qubits. That is what nature refuses to give you for free when you live at room temperature, breathing air, bathing in light, existing as a warm, wet creature in a warm, wet world. Now here is the twist that makes decoherence feel almost philosophical. Decoherence explains why the world looks classical, but it also exposes something unsettling about what you call reality. Because what you experience as a single solid outcome is, in this view, not the universe selecting one truth. It is the universe splitting into many truths and then locking the doors between them so thoroughly that each truth becomes self-contained. And inside a self-contained branch, everything looks normal. You have memories that align. You have records that agree. You have a coherent story that appears to be the only story. This is why the many worlds idea can feel unfalsifiable from the inside. Your branch contains evidence of itself. Your photos, your scars, your history, your data, your science, they all live inside the same sealed narrative. You can test quantum mechanics and confirm its equations to absurd precision. But the branching structure that those equations imply is not something you can look at in the ordinary sense, because looking is the act that spreads information and deepens the separation. The moment you try to catch the branches, you become part of the process that hides them. And yet, the branches are not metaphors. If the theory is correct, they are as physically real as the atoms in your hand. They simply do not interact with you anymore, because interaction is what made them separate in the first place. It is like trying to hear a whisper after you have already slammed 1,000 doors between you and the room where it was spoken. The whisper still happened. The sound waves still traveled. But now, the air that carried them is sealed away behind barriers you cannot undo. This is where the story stops being about particles and starts being about you. Because you are not outside this. You are not a spectator watching the universe branch. You are a system made of quantum parts that constantly decohere into a stable pattern called your life. Your brain is a physical process. Your memories are physical records. Your sense of continuity is a physical thread. And in the many worlds view, that thread is not a single rope, It is a braided cable of near-identical strands that separate, almost rejoin, separate again, and continue, each strand carrying a version of you that feels just as centered, just as real, just as convinced it is the one true continuation. This is the point where people ask a question that sounds simple but is actually a trapdoor. If there are branches, which one is really you? The honest answer is that physics does not contain a label for the real you. Physics contains dynamics. It contains laws. It contains patterns that persist. The you-ness of you is not a particle you can locate. It is a process, an evolving structure that holds together long enough to call itself a self. In classical life, that process is stable enough that identity feels obvious. You remember yesterday. You inhabit the same body. You recognize your name. Your friends recognize your face. But in a branching universe, identity is less like a point and more like a family tree. It has a trunk, your past, and then a fan of futures that are all equally legitimate continuations of that trunk. Each future inherits your memories up to the split, and then writes its own chapter. You can fight this idea if you want. You can insist there must be one privileged line, one true timeline, one chosen track. But insisting does not change the math. The math, taken literally, suggests something wilder, that what you call one life is actually a slice through a vast branching structure, and your sense of singularity is the local feeling of being inside one slice. And if that feels like it melts the meaning out of choices, pause there, because that is the wrong conclusion. Many worlds does not say your choices are fake. It says choices are physical events that correlate you with outcomes. In each branch, a decision still has consequences. Cause and effect still holds. Responsibility still exists inside the story you inhabit. The fact that other branches exist does not remove the weight of this branch. It simply means reality is larger than the one hallway you are walking down. The deeper discomfort is not about morality. It is about scale. Decoherence tells us that the universe does not just contain galaxies and black holes and ancient light. It contains an astronomical number of parallel, non-communicating histories, some differing by a dust mote, some diverging into lives you would not recognize, some turning on microscopic fluctuations that quietly steer whole civilizations. And if that is true, then reality is not a single thing. It is a sprawling library of outcomes, each book sealed inside its own cover, each one reading itself into existence through the simple act of interacting with its surroundings. So now we reach the question that forces the whole discussion to grow teeth. If decoherence explains why branches don't talk, and probability explains why you should expect typical branches, what happens as time piles up? What happens as the universe keeps branching and branching and branching, while you, inside one branch, keep calling your experience the world? The answer is not in a punchline. It's in the slow, unsettling fact that the universe is not obligated to be singular just because your mind prefers it that way. Probability is the word that feels friendly until the universe stops behaving like a coin. In ordinary life, 50-50 means one outcome wins and the other loses, and if you repeat the trial enough times, the chaos averages out into something stable. The world feels like a single hallway with doors you either walk through or you do not. But in the many worlds picture, the hallway is an illusion. The doors do not eliminate alternatives, they multiply them. Heads happens, tails happens. The universe does not choose, it branches. So when you say the probability is 50%, you are no longer describing whether an outcome will occur, because both outcomes occur. You are describing something colder and harder to picture. How much of reality looks like heads versus how much looks like tails after the branching is done. This is where the story turns from strange to destabilizing. Not because it becomes mystical, but because it forces you to admit
Your intuition about chance was built for a world with one history. Quantum theory does not start with probabilities the way your mind wants it to. It starts with amplitudes, complex numbers that can interfere like waves. You do not add probabilities in quantum mechanics. You add amplitudes, and only at the end do you square them to get probabilities. That squaring rule, the Born rule, is not a philosophical preference. It is one of the most brutally confirmed features of modern physics. It is what makes the math line up with the lab. In the usual story, the Born rule tells you the likelihood that a single outcome will be selected. But in many worlds, that can't be what it means, because there is no single selection.
The wave function does not collapse. Everything that can happen does happen, at least in principle. So the Born rule has to be reinterpreted. It becomes a rule about branch weight, sometimes described as thickness. Not thickness you can see, not thickness you can feel, but a measure built into the math of how much of the total wave function ends up in one outcome versus another after decoherence has done its work. Decoherence is the quiet engine behind this entire conversation. It is what happens when a quantum system interacts with its environment. Air molecules, photons, thermal vibrations, everything. The system's different possibilities stop interfering with each other because the environment records which possibility happened. Not in a human sense, not with intention, but physically. The information leaks out into the world. The branches become effectively isolated. They do not separate with a visible wall. They simply become unable to recombine in any practical way. That's why the world looks classical to you. You do not see interference patterns in the behavior of chairs and oceans and people, because the environment has already shredded the delicate quantum overlap into distinct, non-interacting histories. Many worlds takes this seriously and says, if decoherence makes branches effectively independent, then we should treat them as real parts of the universal wave function, not alternate fantasies, not potential outcomes. Real. Now, here's the problem nobody escapes. If all outcomes occur, what does likely even mean? In everyday life, likely is a forecast. It tells you what will probably happen next. But in many worlds, next is a fork. Every outcome happens. So likelihood can't mean which outcome occurs. It has to mean something like which outcome you should expect to experience. And the moment you say that, you have stepped into a deeper kind of uncertainty, indexical uncertainty. Uncertainty not about physics, but about your location inside physics. Not what will happen, but which copy of me will I be after the branching. You can feel how slippery that is, because you never meet the other copies. You never compare notes. You simply wake up inside one branch and call it reality. Some people try to rescue normal probability by saying, you should weight your expectations by branch weight. Thick branches correspond to outcomes with large Born rule probabilities. Thin branches correspond to outcomes with small probabilities. So a rational observer before an experiment should expect to find themselves in a thick branch more often than in a thin one. This is the typicality approach. The idea that most observers, most of the time, will experience outcomes consistent with the Born rule, because the vast majority of observer moments are located in thick branches. It sounds reasonable. It even sounds inevitable. But it hides a small philosophical bomb. It assumes that most is a stable concept when reality contains an enormous, possibly uncountable, set of branches. What exactly are we counting? Branches? Observer moments? Conscious histories? The measure you choose matters, and different measures can produce different intuitions about what is typical. This is not armchair wordplay. It's the difference between probability being a law of nature and probability being a bookkeeping choice. And then the second bomb goes off. From the inside of experience, you never feel branch weight. You do not live inside a histogram. You live inside a story. A thin branch does not look thin. It still has sunlight, gravity, coffee, texts, memories. fear, relief. The people in it are not transparent. The world does not render at lower resolution because the amplitude is small. A branch with a probability of 1 in a billion is still a full universe to the person inside it. So if the many worlds picture is right, there is a permanent mismatch between the third-person view and the first-person view. Third person, the thick branches dominate the measure of reality. First person, you only ever experience whatever branch you are in, and you treat it as the only world because you cannot access the others.
This is where a selection effect starts to creep in, and it does not announce itself. Selection effects are the universe's way of creating illusions without lying. You observe a world compatible with observers because incompatible worlds do not contain observers to do the observing. That is the anthropic principle in its simplest form. Many worlds invites a more personal version. You observe the branches compatible with your continued observation because branches that end your ability to observe contain no observer left to register the ending. This does not require the universe to favor you. It does not require protection. It is not destiny. It is a basic constraint. Experience can only exist where experience exists. The uncomfortable part is what it does to your interpretation of your past. Near misses, recoveries, timing, narrow escapes, these feel like luck in a single world story. In a branching story, they can also be a filter, not a conscious filter, a mathematical one. The branches in which the story stops do not get to produce a narrator. The branches in which the story continues are the only ones that accumulate memory, meaning, and the feeling of an uninterrupted thread. Now pause and notice the tension. If you take branch weights seriously, you might say, yes, thin survival branches exist, but they are tiny in measure. Most of reality, most observer moments, sit in branches where the ordinary statistical expectations play out. That would mean, from the outside, the typical experience is not miraculous. The typical experience is boringly consistent with probability. But from the inside, your only experience is the branch you inhabit. You can't average across branches. You can't step out and compare. So you may be living in a thin branch without ever knowing it because there is no internal sensation of typicality. And that creates a disturbing possibility. A first-person experience could be biased toward persistence in a way that is invisible from the inside. At this point, critics raise a practical objection that sounds like a relief. They say, most real-world outcomes are classical and effectively deterministic. Everyday events involve trillions of particles, and quantum randomness washes out. If that's true, then branching does not constantly give you meaningful alternatives. The outcome is fixed, and there is no branch where it goes differently in any way that matters. So the selection effect collapses. The story ends normally. The universe does not keep producing escape branches. This objection feels comforting because it restores a single track. But it might be too quick, because classical does not mean non-quantum. Classical behavior often emerges from quantum rules through decoherence, and even when outcomes look deterministic, complex systems can amplify microscopic differences. Chaotic systems, weather, ecosystems, and yes, biological bodies can take tiny fluctuations and blow them up into macroscopic divergence. The flutter that becomes a storm is not just poetry, it's a property of nonlinear dynamics. If quantum fluctuations can feed into chaotic amplification, then washing out is not the whole story. Small differences can matter, and if small differences can matter, then branching can matter in the very places you would most like it to be irrelevant. Biology, in particular, is an uncomfortable battleground for this question. A living body is not a clean mechanical clock. It is a vast, noisy, self-correcting, failure-prone system hovering on the edge of stability. Ion channels open and close, proteins fold correctly or incorrectly. DNA repair succeeds or fails. Immune responses either contain a threat or do not. Many of these processes involve randomness at the molecular level,
and some of that randomness may trace back to quantum events. Not in a neat Hollywood way, but in the slow accumulation of microscopic contingencies. If so, then the boundary between classical inevitability and quantum possibility is not a wall. It is a fog. And if the boundary is fog, then the space for branches that differ in outcomes that matter, outcomes with real stakes, may be larger than we intuitively want. But even if we grant all that, the probability problem remains. If survival branches get thinner over time, if continued persistence requires an ever more improbable chain of contingencies, then what should you expect? A third-person statistician would say, the measure concentrates elsewhere. The thick branches overwhelmingly contain the ordinary ending. A first-person witness would say, I can only ever find myself where finding myself is possible. The ending is not an experience I can have, by definition, so expectation becomes ambiguous. What should happen and what can be experienced are no longer the same sentence. This is why some philosophers and physicists try to anchor probability in decision theory, how rational agents should act when they know branching will occur. The idea is not to solve metaphysics, but to pin down practical meaning. If you live in a many-worlds universe and you are about to perform an experiment with different branch weights, how should you place bets? How should you make choices? The surprising claim is that you can derive the Born rule as the only consistent way a rational agent should distribute their preferences across future copies. You don't need the universe to pick an outcome. You just need to define what rational behavior looks like when all outcomes occur and you care about what your future selves will experience. It's clever, it's mathematically elegant, and it still leaves the emotional center untouched, because rational betting doesn't tell you what it feels like to wake up in one branch rather than another. And that's the core unease. Many worlds can make probability work on paper while leaving human intuition stranded. Your mind craves a single future you can point to. Many worlds gives you a fan of futures and then tells you to use branch weights like a compass. But a compass does not keep you from getting lost if the terrain itself is a maze. The terrain here is personal identity. After branching, there isn't one you. There are multiple continuations, multiple streams with your memories up to the split, each convinced they are the authentic continuation. So when you say, I expect outcome A, who is the I doing the expecting? Is it a single pre-branch observer trying to predict where they will end up? Or is it a bundle of future observers, all of whom will exist, with expectation meaning nothing more than how many of them will report seeing A versus B? Now bring that back to the lived human question. Why do some people feel as if they have been spared repeatedly? Why do near-miss narratives feel almost designed? In a single world story, this is where people reach for fate, purpose, signs. In a branching story, you don't need fate to produce that feeling. You only need the logic of memory. The branches that end don't write diaries. The branches that continue fill libraries. The survivorship narrative becomes loud not because it is favored by the universe, but because it is the only narrative that can persist long enough to be told. The universe doesn't whisper meaning into your life. Your life becomes a microphone for whatever continues. And here is the pivot that changes the tone of everything. If probability is branch weight, and if first-person experience is restricted to branches that contain experience, then expectation might not be a neutral forecast. It might be a filter. Not a comforting filter, a mechanical one. A rule that doesn't care about your hopes, only about continuity. That means the phrase, against all odds, becomes strange, because all odds is a third-person accounting statement, while I am here is a first-person fact. And those two statements can conflict without either one being wrong. From the outside, your continued existence in a wildly improbable chain could be an extreme outlier. From the inside, it is just Tuesday. It is just your life. It is just the only story you've ever known. So when you hear someone say, "I beat the odds," you should wonder what they mean by odds.
Do they mean the measure of branches? Do they mean the experiences available to a continuing observer? Do they mean typicality? Or do they mean something simpler, that they are alive, and that aliveness makes the world feel personally arranged, even when the universe is indifferent? In many worlds, that feeling becomes not evidence of meaning, but a predictable side effect of selection. Survival narratives accumulate because only survival narratives can be narrated. This does not prove anything about which interpretation is true. Many worlds might be wrong. Collapse might be real. The wave function might not describe physical reality the way we think it does. Consciousness might not track branching the way a simple physical story assumes. There may be a missing ingredient. But the reason probability matters is that it's the crack where all these uncertainties leak into your life. If probability is about what will happen, you can relax into statistics. If probability is about how much happens, you have to accept that reality contains outcomes you will never witness and histories you will never live while still being real. And if probability is also about which histories can be experienced, then your intuition about endings, about what it means to expect the lights to go out, becomes less solid than you want it to be. Because in the end, the most unsettling possibility is not that there are countless worlds. It's that your first-person story could be biased toward continuation in a way that is impossible to detect from the inside. Not because you are special, not because the universe protects you, not because fate intervenes, but because experience cannot report its own absence. And so the only realities that ever feel like realities are the ones where a witness remains. And if that's true, then the scale we're talking about is not just cosmic distance. It is the scale of possibility itself. It is the scale of how many histories exist, how they are weighted, and how a conscious mind is forced, without choosing, into whatever fraction of those histories still contains a mind to notice anything at all. And now we reach the only moment that matters to the person watching this at night, in a quiet room, with the screen dimmed and the world finally off your shoulders. Not the equations, not the arguments, not the labels we slap onto interpretations like we're sorting reality into neat folders. The moment that matters is the one you will face again and again in your life. You close your eyes and you hand yourself to whatever the universe is doing underneath your awareness. You do it every night. You do it when you faint from exhaustion. You do it under anesthesia. You do it when grief is too heavy and sleep becomes the only mercy you can afford. And one day, you will close your eyes in a way that feels final. The scary part is not that we don't have an answer. The scary part is that physics has become strange enough that multiple answers can fit the same laboratory data, and the difference between them might live entirely in what it means to be an observer, what it means to be you. So let's be honest, in the same ruthless way the cosmos is honest. Quantum mechanics works. It works with a precision that borders on cruel. It predicts what experiments will show to more decimal places than your intuition can even visualize. But quantum mechanics does not tell you what reality is. It tells you what reality does, what outcomes you should expect when you build a measurement and ask nature a question. That gap between doing and being is where the interpretations live. Collapse, no collapse, hidden variables, many worlds, objective collapse models, information-first views. The equations can be the same, while the story of what they mean changes dramatically. And that means the deepest questions you care about, death, identity, continuity, the feeling of being a single thread, are not answered by the success of the math alone. The math is the flashlight. It doesn't automatically tell you what creature is standing in the dark. Many worlds is compelling because it refuses to add extra rules. It looks at the Schrödinger equation, smooth, deterministic evolution, and says, fine, let it run everywhere. No special exception for measurement. No mysterious moment where physics changes its mind. Instead, the strangeness is paid for in branching. The universe does not pick.
it differentiates. You do not get a single result.
You get a set of results that can no longer interfere because decoherence has turned overlap into separation so complete it might as well be a wall. If you accept that picture, then you inherit a new kind of terror. Probability becomes branch weight, identity becomes branch relative, and what happens next becomes a question about where experience can exist at all. The philosophical shock is not that there are other branches. It is that you cannot stand outside yourself to verify what typical means inside a branching reality. You only ever wake up in one thread, and that thread will always feel like the whole tapestry. This is why the immortality question, in the quantum sense, is so hypnotic. Not because it promises comfort, but because it weaponizes a simple truth. Absence cannot report itself. If a history contains no observer, that history contains no one to describe it. If your experience ends in some branch, the ending is not a scene you watch, it is simply the point where narration stops. So from the inside, continuity has a built-in bias, not because the universe is kind, not because fate is real, because experience is a filter. The only states you can ever experience are states that contain experience. That sounds trivial until you realize it can make the future feel deceptively stable. You might look back on your life and count the times you shouldn't have made it, the close calls, the narrow escapes, the recovery that surprised everyone, and you might feel as if something is pulling you forward. In a single world story, that feeling becomes destiny. In a branching story, it can become selection. The branches that ended did not get to become memories. The branches that continued filled the archive. But even here, we have to slow down, because there is a trap inside the trap. Many worlds makes it easy to confuse possible with likely, and easy to confuse exists somewhere with will be experienced by me. Branches can be real and still be vanishingly small in measure. The Born rule does not go away just because you stop talking about collapse. It returns as a waiting. Most observer moments might live in thick branches where outcomes follow ordinary expectations, and the branches where the story continues in wildly improbable ways might be so thin that calling them rare is an understatement. A thin branch is still real. But if you care about what you should rationally expect, weight matters. That tension between the reality of thin branches and the dominance of thick ones is the unresolved heartbeat of the probability problem. It is why serious people can stare at the same equations and come away with completely different intuitions about what should happen. There is also the question nobody likes because it is too practical to be poetic. What if the kinds of branching differences that matter for life and death are not always available? What if, at the scale where bodies fail, the dynamics become effectively locked in, not by fate, but by coarse-grained determinism? What if some endings are not decided by a single delicate quantum coin flip, but by macroscopic cascades where the initial uncertainties have already washed into a single outcome? In that case, the seductive idea of infinite escape routes shrinks, not to zero, but to something less cinematic, something more like ordinary life. You are fragile, the world is indifferent, and the ending comes when biology can no longer keep the lights on. Many worlds does not automatically rescue you from that. It just relocates the mystery to the boundary between quantum possibility and classical inevitability, a boundary we still do not fully understand. So where does that leave you, the person who has to live inside one timeline no matter what the cosmos is doing behind the curtain? It leaves you in the most honest position a thinking creature can occupy: uncertainty with clarity. You do not have to pretend the universe is simple. You also do not have to pretend the weirdest possibility is guaranteed. The truth might be mundane. The truth might be stranger than anything said here. The truth might be something we have not invented language for yet. What you can do is hold the possibilities in your hands without squeezing them into a single comforting story. Here are the 3 cleanest ways to think about it,
without pretending we know more than we do. 1. Collapse is real in some fundamental sense. The wave function does not represent physical reality directly. It represents information, prediction, or a tool, and measurement produces a single outcome in an objective way. In that picture, there is one history, and when experience ends, it ends. 2. Many worlds is correct as a description of physical evolution, but personal identity is not the kind of object that threads indefinitely through branching. The universe branches, yes, but you do not survive as a single continuous entity across infinite splits in any meaningful sense.
You are a process, and processes end. 3. Many worlds is correct, and identity tracks continuity of experience within a branch, meaning the only experiences that can occur are experiences where you continue, which creates a first-person bias toward persistence that can feel indistinguishable from inevitability. Each of these views has costs. None of them is free. Each of them forces you to sacrifice a piece of intuition you probably wanted to keep. And that's the final twist. The universe is not just big in distance. It is big in interpretation. The scale that matters here is not the number of stars. It is the number of ways reality can be consistent with the same facts, while still changing what it means to be alive. When you learn astronomy, you feel small because you picture galaxies. When you learn quantum foundations, you feel small because you realize your mind may be standing on concepts that are not built to match the underlying machinery. Our brains evolved to throw spears, read faces, and survive winter. And now we are trying to use those same brains to understand a reality where outcome may not mean what we think it means, and where self may not be a single line. So here is the only sane takeaway. Sane in the sense of usable, not comforting. Live as though choices matter, because from inside your branch, they do. Love people as though time is limited, because in every interpretation we take seriously, it is. Build meaning as though you are not guaranteed anything, because you aren't. And keep your curiosity sharp, because curiosity is the one thing that scales with the universe. It gets bigger when the universe gets bigger. It does not collapse under the weight of mystery. It becomes the way you carry the weight. Tonight, when you close your eyes, you won't be thinking about amplitudes. You'll be thinking about your life, about the people you haven't replied to, about the regrets you keep replaying, about the strange fact that you are a piece of matter that can ask questions about itself. And whatever is true about the deepest structure of reality, that fact remains miraculous in the most literal way. It does not have to be the case. The universe could have been a place with no witnesses, no thoughts, no stories. Instead, here you are, awake, aware, staring into the dark and daring it to make sense. If this felt unsettling, good. Not because fear is the goal, but because discomfort is often the price of touching something real. The old picture of reality was comfortable because it was simple. The new picture is uncomfortable because it might be honest. And if you're listening to this late at night, the discomfort isn't an enemy. It's a reminder that you're still here, still thinking, still alive enough to be confused. And now, I want to hear from you. In the comments, tell me which possibility feels most plausible to your mind and which feels most plausible to your gut, because those are rarely the same answer. Does the many worlds idea make you feel expanded, like reality has more room than you imagined, or does it make you feel trapped, like meaning dissolves into an infinite branching noise? And what should we explore next? Time dilation, black hole horizons, the measurement problem, or the terrifying physics of the vacuum itself? If you enjoyed this kind of calm, long-form investigation, please like the video, subscribe, and keep the notifications on, because we're going to keep pulling at the same thread until the universe either unravels or shows us a pattern we can finally recognize.